Hi guys, welcome back for part 2 of Java optional. In this part, we're going to be taking a look at these functional methods, which were not covered in part 1. If you want the link to part 1, it's going to be down in the description section below. All right, so let's continue off where we stopped, which is we looked at the map method in part 1. Okay, so in this case here, I've got 4 variants of a method called orElse. Let's take a look at the first 2, which have to deal with returning the value of the optional. So we are still executing a probe for an optional conflict. Okay, same thing as the examples before. And in this case, the orElse method is going to say if the value in the optional is present, then return it. And there's a conflict type. There's the value inside the optional. If it's not, if it's empty, then I want you to execute whatever piece of code's in here in order to return to me another type of conflict. Now in this case, this is a local method that I created that returns a default conflict which has a conflict ID of -1. And I did that to differentiate it between other conflicts ID in the example. If we run this right now, we'll see that there's a log message that says that that orElse clause actually got executed, but it reports that the conflict ID is 43, and it really should report -1. So there's something weird going on here. And if I continue executing this, you'll see that it always gets called until you eventually get to a situation where, you know what, it actually was missing the value, and you can actually see it's -1. So why is this happening? You see, orElse always executes. It executes eagerly. It doesn't matter if the value is there or not. It's 100% of the time going to execute. Now that could be problematic for you because whatever's getting executed in here might have considerable overhead. And I can tell you from personal experience, building a conflict in an air traffic control system is a heavyweight object to create. So this is not desirable to have executed when it's not needed. Okay, so that eager instantiation or that eager execution in this use case is really not desirable. So how do we fix that? Well, there's another alternative that I can use here, and that's exactly what we're going to take a look at next, and that is the orElseGet. All right, so let's take a look at how this is different. The orElseGet is pretty much identical to the orElse, except that it takes in a supplier. Okay, and that supplier now only gets executed when the value is missing in the optional. So if I run this now, yes, in this case it was missing, so it did get called, and you can confirm that because it's -1. But eventually, as I continue re-executing this, you'll see that the value is present. Its conflict ID is 27, and you don't get the log message that get default conflict got executed. So this is a lazy execution, which is great. So now we have a solution to bypass that overhead. And I tend to gravitate towards those suppliers because over time, those objects that might not be heavyweight to create eventually become heavyweight as the project continues to, develop. So now we're going to take a look at the OR. OR of optional was introduced in Java 9. Okay, now OR is a little bit different than the other 2 examples we saw because it doesn't return the value of the optional. It's actually geared towards returning an optional itself. So OR is going to say, all right, is there a value in this optional? If it is, then return it. You can see here in the return type, we're actually returning an optional. If it's empty, then I want you to use the supplier, right, lazy execution, to create another optional, perhaps a default optional. So again, here I'm calling the default conflict method to create that conflict ID with -1. Now this is a great method to execute in a client-facing method that's potentially going to return null, or in this case, returning an optional of a type. Okay, so I put it kind of outside the probe for conflict returning optional method because I didn't want to come up with too many copy-pasted versions of that method so we didn't have to go back and forth between files. So this is a great candidate when you want to return an optional or a default optional. If I execute this, you can see that it didn't return anything, and the reason for that is because the value was present, so all it did was return it. But if I continue going on here, eventually the OR will say that value is missing and will execute this supplier, and that get default conflict has a log message in there that gets logged. Okay, so let's go on to our last variant, which has to deal with throwing exceptions. So sometimes you might want to throw an exception based off if the value in that optional is present or not. So over here, the orElseThrow says if the value is present in the optional, then I want you to return it. And there you go, you have the return type conflict. If it is empty, however, I want you to execute the supplier, and I'm using a method return type here to actually throw an exception. So my recommendation for you is if this is an exception that's not expensive to create, doesn't have a very deep stack trace, then by all means you can go with that. Or you might prefer to return instead an empty conflict, for example, incorporate a null object design pattern, or you might want to create a default optional. You have now 3 different ways to go about that depending on your use case. Let's execute this method. You can see right away we'll get a conflict here, no conflict exception because the value was missing. If I continue on, eventually I get to the point where the value is present and there's no stack trace that gets thrown or printed, no exception that gets thrown, and I got my conflict here that gets returned. All right, so now we're at the last 2 examples that have to deal with lists. There are times that you're going to have to deal with lists of optionals. I don't recommend using list of optionals. It can get kind of complicated. Well, let's take a look in a second here. Over here, I create 3 optional conflicts. You can see that 2 are actually present in there and 1 is actually empty. We're going to build a list of these, and we're going to get back a list of optional conflicts. So hence, you start seeing here nested brackets. It gets even more complicated if, let's say, conflict returned a member that returns an optional field. So there are places you do not want to use optional, and I actually go through where those places are in my blog post here. If you click on my site, mvpjava.com, and you go in there, you'll see where I describe that. We're going to work with streams here. So we're going to execute the stream method off the list, and we're going to start filtering for if those conflicts are actually present or not using the filter method. So the filter method, taking a predicate, we're going to be using the optional, and we're going to be using what I covered in part 1, which is the isPresent. We want to guard. We want to say if that value is present, return the Boolean to tell me if it's actually present or not. And if it is present, I want to actually map to get the value out. So you notice I'm using method references off of the optional to tell me if the value is present, and then if it is, to go map and get me that value. Once I can get those values, I can collect them into a list using a collector, get a list of conflicts, and then print them all out in a nice for each. And you can see here that I get the 2 that are actually part of the 3 in my test case over here. Okay, so working with optionals in streams, in lists, I don't recommend using optionals in lists, but if you do have to use them, then I'm going to show you another way that you can cut down on this kind of verbosity by using a new method that was introduced in Java 9 of the optional called stream. And we're also going to take a look at FlatMap. So in this case here, it's almost an identical use case except that only 1 out of the 3 optionals have an actual value. I still build a list of optional conflicts. I still call the stream method off the list, so I get effectively a stream of optional conflicts as before, except that now I only got 1 line here, okay? And this 1 line is actually going to replace these 2 lines here and also the isPresent in the get within those 2 lines. So let me explain. Stream says this: if the value is present in optional, return to me a stream of that value. Now, in this case, optional only holds a single value, so you get a stream of 1 value of a conflict. If it's empty, return to me an empty stream. So in effect, what's going on is you're getting back a stream of conflicts. Now, what's going to happen is if you were using map, we would get in a situation where you would get a stream of conflicts, and that gets more complicated to deal with. So FlatMap will flatten this so you can end up with only a single stream of conflicts. So this is a nifty way to not have to remember to do an isPresent, a get. We actually use a stream to do that, and we flatten the map to get a single stream instead of a stream of streams with FlatMap. Very nice method. Then we just collect everything and loop through the list. And we just get one conflict, which is this one over here that randomly generated an ID of 75. So there you have it, guys. You have now a nice repertoire of functional methods in dealing with an optional, whether you want to return an optional, whether you want to extract an optional that got returned. And now you have different mechanisms to apply to your use cases. I really hope you enjoyed that. If you did, give me a thumbs up and don't forget to leave a comment below. Okay, guys, until next time. Ciao.